Week 9 focused on answering the question, are conventional transportation options sustainable? In your course material and discussions, you explored the answers to these questions related to sustainable transportation. What are conventional transportation options? How do conventional transportation options work? What sustainability implications are associated with conventional transportation options? What factors affect how these implications change over time and space? And how can we compare these implications quantitatively through sustainability indicators? We identified early on in the Week 9 intro video that the conventional transportation options we will be focusing on are passenger vehicles fueled by gasoline or diesel, which are derived from petroleum. This was because gasoline and diesel-fired passenger vehicles comprise the largest share of total energy use for transportation. In fact, gasoline consumption is so high in this country that Americans use more than 1 gallon of gasoline per person per day. There are many alternatives to this transportation mode and fuel combination that could possibly be implemented for more sustainable transportation. You watched a video that explained how the gasoline-powered internal combustion engine, also known as the Otto cycle, works. You also watched a video that explained how a diesel-powered engine works. Both engines use pistons connected to a crankshaft, and the up and down motion of the pistons creates the rotary motion needed for the wheels to move forward. Both diesel engines and gasoline engines convert fuel into energy through a series of small explosions or combustions. The main difference between the two engines is the way these explosions happen. In a gasoline engine, fuel is mixed with air, compressed by pistons, and ignited by sparks from spark plugs. In a diesel engine, however, the air is compressed first, and then the fuel is injected. Because air heats up when it's compressed, the fuel ignites without a spark plug. These differences have implications for efficiency and emissions, as you saw in your readings. Gasoline and diesel both come from refined crude oil. A typical barrel of crude oil will produce about 45 gallons of petroleum products. Gasoline makes up the largest share at 43%, and diesel the next largest share at 25%. The readings from this week were organized by sustainability category and fuel type. The single biggest factor in the price of gasoline is the cost of the crude oil from which it is refined. The United States and many other countries in the world consume more petroleum products than can be produced without using crude oil that is imported from other countries. At the same time, certain countries export more crude oil than they consume. When crude oil supplies from one country or source drop off, world oil demand is still met, but with a different mix of crude oil supplies. When the overall supply of crude oil decreases, the world market tightens and prices usually rise. For this reason, individual boycotts of certain fueling stations or fuel companies are not very effective at impacting gasoline prices. It would take boycotts from entire groups of countries to have an impact on fuel prices because the price of crude oil is set in a global market. The next largest components of gasoline prices are taxes and refining costs. Federal excise taxes are currently 18 cents per gallon. 12 states levy additional state sales and other taxes on gasoline, and some counties and cities add extra taxes. Refining costs and profits vary from region to region of the United States, partly due to the different gasoline formulations required in different parts of the country. The characteristics of the gasoline produced depend on the type of crude oil that is used and the type of processing technology available at the refinery where it is produced. Taxes are one area in which consumers can affect prices by voting for or against certain taxes. Distribution, marketing, and retail dealer costs and profits make up the remainder of the retail price of gasoline. Most gasoline is shipped from the refinery first by pipeline to terminals near consuming areas where it may be blended with other products such as ethanol to meet local government and market specifications, and is then delivered by tank or truck to individual gasoline stations. Some retail outlets are owned and operated by refiners, while others are independent businesses that purchase gasoline from refiners and marketers for resale to the public. The price on the pump includes the retailer's cost to purchase the finished gasoline and the costs of operating the service station. It all reflects local market conditions and factors, such as the desirability of the location and the marketing strategy of the owner. The cost of doing business by individual dealers can vary greatly depending on where the dealer is located. These costs include wages and salaries, benefits, equipment, lease, rent, insurance, overhead, and state and local fees. Even retail stations next to each other can have different traffic patterns, rents, and sources of supply that affect their prices. The number and location of local competitors can also affect prices. This is another area in which consumers can affect prices. If a large enough group of consumers increase or decrease demand at certain fueling stations, it sends a market signal to retailers to lower or increase their marketing costs, which ultimately affects the price at the pump. The main component in the price of diesel fuel is also the global price of crude oil, and other components follow a similar trend as gasoline. International diesel fuel demand can affect United States prices. Many other countries rely even more heavily on distillate fuels, specifically diesel fuel, than the United States does. This is the case in Europe, where demand for diesel has grown rapidly as cars and light-duty trucks have been moving from gasoline to diesel fuel. Diesel-fueled vehicles now represent over half of the new car and light-duty truck sales in that region of the world. Europe uses about a quarter of the world's distillate, heating oil, and diesel, so it represents a significant factor in the high growth of world distillate demand. Prices of transportation fuels are generally more volatile than prices of other commodities, because the United States vehicle fleet is so heavily dependent on petroleum and few alternative fuels are available. If supply declines unexpectedly due to refinery problems or lagging imports, diesel inventories may decline rapidly. When inventories are low or falling, some wholesalers and marketers may bid higher for available product. If the diesel fuel transportation system cannot support the flow of supplies from one region to another quickly, prices will remain comparatively high. These are normal price fluctuations experienced in all commodity markets. Transportation costs generally increase with distance between the retail location and distribution terminals and refineries. Areas farthest from the Gulf Coast, the source of nearly half of the diesel fuel produced in the United States, tend to have higher prices. The cost of doing business can vary greatly depending on where a dealer is located. Similar to gasoline stations, even retail diesel stations next to each other can have different traffic patterns, rents, and sources of supply that affect their prices. The number and location of local competitors can also affect prices. Also, high-volume truck stops that cater to fill-ups by large commercial vehicles tend to offer diesel fuel at a lower price than small-volume service stations that mostly deal with privately owned, gasoline-powered automobiles. Thousands of people die each year due to air pollution related to fossil fuel combustion. Health effects such as asthma, skin, eye, and throat irritation, headaches, poor lung development, cancer, heart disease, lung disease, chronic obstructive pulmonary disease, all could be cutting people's lives short by as much as 9 years. The higher the level of concentration of transport activities, the higher their environmental impacts are being felt by the local community. Criteria and hazardous air pollutants emitted from the combustion of gasoline and diesel in transportation systems are the cause of many of these environmental and health effects. Criteria air pollutants are pollutants that are regulated by the United States Environmental Protection Agency under the Clean Air Act and are indicators of air quality commonly found all over the country. They include carbon monoxide, sulfur oxides, nitrogen oxides, ozone, lead, and particulate matter. Hazardous pollutants include volatile organic compounds and mercury. Unlike greenhouse gas emissions, which contribute to global climate change, criteria and hazardous pollutants often have local and regional consequences and not global effects. Carbon monoxide is a colorless, odorless gas, the result of the incomplete combustion of hydrocarbons. Transportation accounts for 70 to 90% of total carbon monoxide emissions. Carbon monoxide is a poisonous gas. The main health effect is that it starves the body of oxygen, causing loss of consciousness and even death. Low concentrations can cause poisoning symptoms in people with heart, lung, and circulatory system weaknesses. It also affects the respiration of plants by inhibiting photosynthesis. Indirectly, carbon monoxide contributes to the formation of greenhouse gases as a catalyst. Sulfur dioxide is a heavy, colorless gas with a strong odor. It is the result of the combustion of fossil fuels like coal and hydrocarbons. Transportation accounts for around 5% of total sulfur dioxide emissions. Although transportation is a minor source of SO2, related activities like oil refining and steel and petrochemical industries are important emitters. Sulfur dioxide causes and worsens respiratory and cardiovascular problems. In sufficient concentration, it irritates the eyes, nose, throat, and lungs and causes discomfort, and even hospitalizations for respiratory illness. The main pollutant effect is from the conversion of sulfur dioxide to sulfuric acid in the atmosphere, which causes an unpleasant haze and acid rain. Sulfur is an essential nutrient for plants, but sulfur dioxide is regarded as an inhibitor of physiological activity. Acid rain can destroy forests and wildlife and damage buildings. Nitrogen oxides, which include NO, NO2, and N2O, are brown, odorless gases which are a byproduct of combustion of all fossil fuels and biomass. Transportation accounts from 45 to 50% of total emissions of nitrogen oxides. Nitrogen oxides cause acute and chronic effects on airways and lung function, asthma attacks, hospitalization, and death for vulnerable people. Nitrogen oxides prevent the growth of crops and thus reduce agricultural yields. They are also a catalyst for ozone, a component of acid rain and a component of smog. Ozone is a colorless gas with a strong odor. It is created naturally in the high atmosphere when an oxygen molecule is broken apart by ultraviolet radiation and combines with another oxygen molecule. Ozone is also the result of the action of light over a mixture of hydrocarbons, volatile organic compounds, and nitrogen oxides in the lower atmosphere. It is thus directly linked with transport emissions, notably in urban areas. Ozone is essential in the upper atmosphere as it absorbs light in the ultraviolet band, but low-level ozone is poisonous, hampers breathing, and irritates the eyes and the respiratory system. It is a secondary pollutant because it is not usually emitted directly, but created at ground level by a chemical reaction between NOx and VOCs in the presence of heat and light. It causes smog and degrades structures through oxidation. It damages crops and vegetation and leads to losses of leaves. Depending on the crops and the concentration involved, ozone may reduce yields from 1 to 20%. Ozone also impairs visibility. Lead is a toxic metal mainly used as an anti-knock agent in gasoline. Until recently, leaded gasoline was a main source of atmospheric lead emissions in developing countries. This contribution has dropped in absolute numbers, but still accounts for 30 to 40% of total emissions. Leaded gasoline has been phased out in the United States since the 1970s. Batteries are now an important source of lead for transportation, but a very limited amount of this lead is carried through the atmosphere. Lead has effects on the metabolism and accumulates in living tissues. It may cause anemia and mental retardation for young children. Lead is fixed by plants and animals and recontaminates the food chain. It has a high potential to accumulate in the environment. Particulates include various solids in suspension in the atmosphere, such as smoke, soot, and dust, and results of the incomplete combustion of fossil fuels. They may also carry traces of other toxic substances like hydrocarbons and volatile organic compounds. Transportation accounts for around 25% of total emissions of particulates. Diesel engines are the main emitters. Particulates are carcinogenic. They are also harmful to lung tissue and worsen respiratory and cardiovascular problems, notably if their size is smaller than 5 microns. PM 2.5 refers to fine particulates which are less than or equal to 2.5 microns and penetrate deep in the lungs. PM 10 are less than or equal to 10 microns. Particulates may alter the aesthetic appeal of structures by blackening them. The accumulation of particulates in the atmosphere and deposition on leaves may reduce photosynthesis and plant growth. Hydrocarbons are a group of chemical compounds composed of carbon and hydrogen. When in a gaseous form, hydrocarbons are called volatile organic compounds, or VOCs. Several hydrocarbons and VOCs are heavy gases or volatile compounds with a strong odor. They are mostly the result of the incomplete combustion of gasoline or byproducts of the petrochemical industry. They include methane, gasoline, and diesel vapors, benzene, formaldehyde, and others. Transportation accounts for 40 to 50% of total emissions of hydrocarbons and VOCs. They can be emitted by incomplete combustion, during refueling, or by evaporation from storage units, particularly gas tanks. For instance, a car parked overnight during summer emits approximately 4 grams of VOCs. All VOCs are carcinogenic to some extent, fatal at high concentrations, harmful to crops, and accumulate within the food chain. However, heavy hydrocarbons are far more carcinogenic than light hydrocarbons. All VOCs have several regional effects. They are components of smog, catalysts for ozone, and components of acid rain. These readings by the EPA compare different vehicle types and fuels across these various air pollutants, along with others. These comparisons show that gasoline-powered vehicles emit more VOCs, THCs, and carbon monoxide than diesel-powered vehicles, but diesel-powered vehicles emit more NOx and particulates than gasoline-powered vehicles, due to the different combustion systems used by each type of vehicle. Particulate emissions are especially problematic with school buses because children are particularly sensitive to the health effects associated with them. There are other environmental and health effects beyond those associated with air pollution. Air pollution fallouts occur when a pollutant goes from an airborne state towards a solute or colloidal state. Water is a very good solvent for several pollutants, notably acid depositions. Fallouts are accelerated and concentrated by rainy conditions. As an important source of air pollution, transportation accounts on a similar scale for fallouts. In some areas, transportation may account for up to 25% of nitrogen fallouts in water. It is estimated that acid rains may account for more than 75% of the growth of acidity of lakes. Since fallouts are a continuous accumulation and occur over a longer period than most water pollution sources, they have a higher impact on still water environments than running water. Several northeastern United States and eastern Canadian lakes have seen their entire fish population destroyed as a result of increased acidity levels. Fallouts of hydrocarbons and VOCs and lead are poisonous and may disrupt marine life if they accumulate in the aquatic food chain. Particulate fallouts, when in sufficient quantities, may increase the turbidity of water and thus reduce the photosynthesis capacity of aquatic plants. After unloading their bulk loads like oil, coal, nitrates, and mineral products, marine vessels require cleaning. Since this practice is restricted in several port and coastal areas, operators wait until they are in international waters to proceed. Oil products residuals carried by tankers are the major source of discharges. It is estimated that for every 1,000,000 tons of oil carried, 1 ton is spilled through washouts. Once a spill has occurred, it is extremely difficult to contain it. Annually, an average of 1.1 million tons of oil comes from discharges, and 400,000 tons are spilled. The effects of these spills depend on the nature of the residue discharged. Petroleum products are the most harmful and include environmental effects like destruction or disruption of aquatic, plant, and animal life, and of shore ecosystems. De-icing of transportation infrastructure, like roads, parking lots, airfields, etc., is almost the only artificial source of salt releases into the environment. High concentrations of salt, notably chlorine ions, in freshwater environments disrupt life cycles and may be fatal to some organisms like larvae. Runoffs from infrastructure will alter the turbidity and the oxygen level of water and contaminate the food chain. De-icing salt has the tendency to accumulate in snow and soils beside roadways. During early springtime, nearly all the salt accumulated will be released into the hydrographic system, where it will contaminate groundwater and interfere with the growth of plants and the reproduction cycle of aquatic life, particularly vulnerable at this time of year. In addition, when a transportation infrastructure is built over a hydrological environment, like a river, wetland, or coastal area, disruption occurs. The maintenance of transportation infrastructure, particularly harbor and waterways, also have a significant impact. Dredging accounts alone for 80% of the waste released into aquatic environments. In addition to health impacts from air and water pollution, conventional transportation options have other social impacts, including noise, odors, aesthetic impacts such as seeing the fallout of diesel fumes on tree leaves in residential neighborhoods, and lifestyle impacts such as not being able to open windows in your own home due to the noise, smell, and health impacts of the transportation system. About 45% of the population in developed countries live in high levels of noise intensity generated by road transportation. Many of these sustainability implications vary over time and space, especially prices. There are two ways to compare recent prices with historical prices. This graph shows the average monthly nominal and real prices of crude oil from 1974 through 2014. The real price is based on the value of the dollar in year 2013. The nominal price compares the price actually paid at the pump. The real price compares the inflation-adjusted price so that prices in the past are in today's dollar value. Crude oil and petroleum product prices are the results of thousands of transactions taking place simultaneously around the world, at all levels of the distribution chain, from crude oil producer to individual consumer. Oil markets are essentially a global auction. The highest bidder will win the available supply. Like any auction, however, the bidder doesn't want to pay too much. When markets are strong or tight, the bidder must be willing to pay a higher premium. When markets are weak or loose, a bidder may choose not to outbid competitors, waiting instead for later, possibly lower priced supplies. In recent years, the world's appetite for gasoline and diesel fuel grew so quickly that suppliers of these fuels had a difficult time keeping up with demand. This demand growth is a key reason why prices of both crude oil and gasoline reached record levels in mid-2008. World oil prices declined sharply in the second half of 2008 from their peak in mid-July of that year. While oil prices have generally trended upwards since that time, the future outlook for crude oil prices is highly uncertain. The U.S. Energy Information Administration considers the implications of a wide range of price scenarios in their short-term energy outlook and the annual energy outlook. The low and high oil price paths presented here are not intended to provide lower and upper bounds for future oil prices, but rather to allow the analysis of a possible future world oil market conditions that differ significantly from those assumed in a business-as-usual case. As mentioned before, retail gasoline prices are mainly affected by crude oil prices and the level of gasoline supply relative to demand. Even when crude oil prices are stable, gasoline prices fluctuate due to seasonal demand and local retail station competition. Gasoline prices can change rapidly if something disrupts the supply of crude oil, or if there are problems at refineries or with delivery pipelines. Retail gasoline prices tend to gradually rise in the spring and peak in late summer when people drive more, and then drop in the winter. Good weather and vacations cause U.S. summer gasoline demand to average about 5% higher than during the rest of the year. Gasoline formulations and specifications also change seasonally. Environmental regulations require that gasoline sold in the summer be less prone to evaporate during warmer weather. This means that refiners must replace cheaper but more evaporative gasoline components with less evaporative but more expensive components. If crude oil prices do not change, gasoline prices typically increase by 10 to 20 cents per gallon from January to Retail gasoline prices tend to be higher the farther it is sold from the source of supply, ports, refineries, and pipeline and blending terminals. About 60% of the crude oil processed by U.S. refineries in 2011 was imported, with most transported by ocean tankers. The U.S. Gulf Coast was the source of about 23% of the gasoline produced in the United States in 2011, and the starting point for most major gasoline pipelines, so those states farther from the refineries will most likely have higher prices. Any event that slows or stops production of gasoline for even a short time, such as planned or unplanned refinery maintenance, or the refinery shutdowns that occurred when the hurricanes Katrina and Rita hit the Gulf Coast in 2005, can prompt bidding for available supplies. If the transportation system cannot support the flow of surplus supplies from one region to another, prices will remain relatively high. Pump prices are often highest in locations with few gasoline stations. Even stations located close together may have different traffic patterns, rents, and sources of supply that influence their pricing. Drivers face a trade-off between stations with high prices and the inconvenience of driving further to a station with lower prices. Some areas of the country are required to use special reformulated gasoline with additives to help reduce carbon monoxide, smog, and toxic air pollutants that result when gasoline is burned or when gasoline evaporates during fueling. Other environmental programs put restrictions on fuel transportation and storage. These programs tend to add to the cost of producing, storing, and distributing gasoline. About a third of the gasoline sold in the United States is reformulated. Each oil company prepares its own reformulation to meet federal emissions standards. This map shows areas that require reformulated gasoline under the Clean Air Act. These requirements will impact prices in these regions. The Clean Air Act is the major law aimed at reducing air pollution in the United States. The price of diesel at the pump is also closely tied to the price of crude oil as shown here. While U.S. diesel fuel demand is fairly consistent and generally reflects the overall health of the economy, there is often a seasonal aspect to diesel fuel price movements. During the fall and winter, diesel fuel prices are affected by the demand for heating oil. Heating oil and diesel fuel make up the product category distillate fuel. They are closely related products, with the main difference being that diesel fuel has lower sulfur content than heating oil. As a result, diesel and heating oil are produced together, and seasonal increases in heating oil demand can put pressure on the diesel fuel market as well. In some regions, diesel fuel prices can also be influenced by seasonal swings in demand for diesel fuel use by farmers. Historically, the average price of diesel fuel has been lower than the average price of gasoline. However, this is not always the case. In some winters where the demand for distillate heating oil is high, the price of diesel fuel has risen above the gasoline price. Since September 2004, the price of diesel fuel has generally been higher than the price of regular gasoline all year round for several reasons. Worldwide demand for diesel fuel and other distillate fuel oils has been increasing steadily, with strong demand in China, Europe, and the United States, putting more pressure on the tight global refining capacity. In the U.S., the transition to ultra-low sulfur diesel fuel has affected diesel fuel production and distribution costs. Also, the federal excise tax on diesel fuel is 6 cents higher per gallon than the tax on gasoline. I have created a spreadsheet that compares many of these sustainability impacts and others across vehicle and fuel type. You can access it below the link for this video on Blackboard. In addition, the Fuel Economy Guide provides comparative fuel economy and annual fuel cost data by vehicle class. Within each class, vehicles are listed alphabetically by manufacturer and model, allowing for direct comparison between vehicles. The guide shows how important fuel economy is to reducing greenhouse gas emissions, with this graph showing annual CO2 emissions by fuel economy in miles per gallon. This indicates that one of the most important things consumers can do now to reduce climate change and other environmental impacts of conventional fuels is to buy a vehicle with a higher fuel economy. This graph from the Fuel Economy Guide shows the fuel economy and annual fuel cost ranges for vehicles in each class. There is a wide range of results for each vehicle class. For that reason, the Fuel Economy website is even more helpful because it allows you to directly compare specific vehicles by fuel economy and emissions. And when you go to buy a car, the new Fuel Economy and Environment label designed by the EPA allows consumers to directly compare vehicles in terms of economic and environmental indicators. Now that you've explored the sustainability impacts associated with conventional transportation options, we will turn our attention to alternative transportation options in Week 10.